Today's lab is experiment number 2, density determination. Concept-wise, today's lab is pretty simple. You take a measurement of the mass of a sample. You also take a measurement of the volume of the sample, and you divide mass by volume, you get density. We're going to measure the mass of different samples. Clearly, we're going to take a lot of measurements. Also, we're going to get the density, which means we're going to operate on the data we get. So there are two things we need to pay special attention to when you finish the lab report. Number one, make sure you report the number to the correct number of sig figs. When you take a measurement, we need to record the number with 1 digit of estimate. So basically, you read the number to 1 digit more than the finest mark on the tool you use. After that, you have to operate on the data you get. You have to do multiplication, division, and maybe some other calculations. When you do this, whenever you do calculations on measurements, always pay attention to the number of significant figures in your answer. Remember, there are two rules. Rule number 1 applies to multiplication, division. Rule number 2 applies to addition, subtraction. You may want to go back to your textbook or lecture PowerPoint to find the rules. Make sure you have the rules in front of you when you try to finish your lab report. Okay, sig figs matters throughout this semester. Make sure you get all the data in the correct number of sig figs. What you don't want to have is that you get all the data, you did all the calculation, however, your sig figs is wrong. Then you lose points on that. Okay, now let's get started. The first section is the measurement of the density of a regular shaped object. We're gonna pick one sample from here and take the first one. Code number 8. Okay, make sure you record 8 on your report sheet. Sample number 8 is what we will use. Okay, so we're gonna measure the mass of it, then we'll measure the volume of it. Well, there's no direct way to measure the volume of this. We're gonna measure the length, width, and the height of it. Okay? Tiller the balance, zero it, put our number 8 sample on. 38.23 grams. 38.23. Record the mass, 38.23. Under first section, density of a regular shaped object, line number 3, mass. Trial number 1, 38.23. Now, we're going to measure the length, width, and height of it. Well, normally we will use a ruler to measure it, but this time we're going to introduce a unique instrument. It's called a caliper. A caliper is used to measure the dimension of an object. Okay, it needs to take some time to talk about how to use it, how to read the number from it. But in this experiment, we're gonna skip that part. I'm just gonna use it to measure, to take the measurement. Okay, I'm gonna measure the length first. I'm gonna open it up, put my sample in, squeeze it, okay, until it cannot be moved anymore. I'm going to take a reading of the length. 8.81 centimeter length. 8.81 centimeter. Width 4.20. 4.20 centimeter. Height 1.86. All right, we got all the data we have. Okay. Length, width, height. You're gonna follow the formula provided to calculate its volume. Again, make sure you follow the operational rule for measurement to make a decision what number you're gonna keep in your volume answer. Okay, and then you get a density. Again, density is mass over volume. Make sure you follow the operational rule for measurements. Okay, I'm gonna take another set of data, doing it in the same way. I just took another set of measurement. Let me read it out to you, the data I got. The length is 8.80. The length is 8.80 centimeter. The width is 4.21 centimeter, 4.21. The height is 1.86, the same as last time, 1.86. And the mass is 38.24. Okay? You do the calculation, you do the average. Again, when you do the average, make sure you keep the right number of sig figs. Now let's move on to the next section. Section number 2 is the density of an irregular shaped object. We have 4 metal beads unknowns: unknown A, unknown B, unknown C, and unknown D. Okay, I'm gonna pick this one. We're gonna measure the density of these metal beads. Unknown C, okay, so record the unknown code on your report sheet. Unknown C, we're gonna measure the density of this one. Some unknown C sample. Okay. Zero the balance. The mass of the unknown C we took is 24.53. 24.53. That's the mass. Now we need to measure the volume of this. How can we do that? How can we measure the volume of these metal beads? Well, this is how we're going to do it. We're going to use a cylinder, a graduated cylinder. We're going to add some water into it first and take a record of the volume of the water added. Then we add the metal beads into it. When you add the metal beads into it, the water inside the surface is going to rise because some of the volume is going to be occupied by these metal beads. Once we add in all the metal beads, we read the volume on top of the water again. The difference of 2 volume readings will be the volume of the beads. I hope that makes sense to you. Okay, we measure the volume of a liquid first, which is water. Then we add the metal beads. The water is going to rise. At the end, we read the volume of the water again. The difference in the change in volume, the difference is the volume of the metal beads. So let's start. Okay, I'll add some water into the cylinder. Let me read the volume. Four point 4.80. The initial volume of water, 4.80. Now we're going to add these metal beads into the water cylinder, to the water. We need to be very careful. You do not want to drop the water beads like this. It may knock the bottom, okay? It's going to break the bottom, or it may spill out some water. You don't want that to happen. So you want to tilt your cylinder, slide your sample one bead at a time. Let it go to the bottom. Okay. And we want to shake it a little bit. Make sure there's no air bubbles on the surface of the beads. Sometimes when you put solid into water, it may bring some air bubbles on the surface of the sample. So mine looks pretty good. There's no bubble. Okay, I'm gonna read the volume again. So hard, 7.60. All right, now you can calculate the volume, the density by yourself. Again, make sure follow the 6 Figs rule. I just did my trial number 2 for the unknown metal bead C. Okay, let me give you the data for trial number 2. The mass of the sample used this time is 20.18 grams, 20.18. The initial volume of water is 5.10, and the final volume of the water is 7.40. Okay, that's another set of measurement of the beads. You can do the calculation and decide what the identity of the unknown metal is. After you're done with your calculation, you have to make a decision about the identity of the metal beads. You're going to choose one from these 4 metals: aluminum, zinc, nickel, and lead. Okay, look at the data you get, compare with this, and make your decision and put it on your report sheet. The last section is the density of an unknown liquid. Okay, we have only one unknown liquid sample. So you just make a note on a report sheet. The unknown used is called unknown liquid. We're going to measure the density of this liquid. Okay, and then make a decision based on the table on the lab manual, okay, about what liquid this is. Okay, so overall what we do, we're going to transfer certain volume, we'll measure the volume, we're going to transfer a certain volume of the liquid, transfer it into a container, like a beaker like this, and then measure the mass of the liquid. We measure the volume of the liquid first, and then we get the mass of the liquid, then we get the density. Okay? We have learned that before last time, basically, in experiment number 1, we said, okay, normally we measure liquid, we use graduated cylinder. Well, today, we're going to use another piece of glassware, a pipette. We call it a volumetric pipette. A volumetric pipette is used to transfer a fixed volume of a liquid. it is more accurate than the graduated cylinder. If you look at the pipette here, you can see here there's only one mark on the pipette, and that mark is the volume you're going to transfer. In this experiment, it says that mark, it says 10 milliliter. So this pipette is used to transfer 10 milliliter of liquid only. How can we use it? I'm going to show you later on when we use it. Okay? So first, measure the temperature of the unknown liquid. I have transferred some unknown liquid to this beaker. Okay? I have let the thermometer sit there for about 3 minutes already. The temperature is 23.0 Celsius. 23.0. Now, this is the beaker that eventually I'm going to transfer the unknown liquid into. So I need to measure the mass of this beaker first. .63. Now I'm going to transfer 10.00 ml of the unknown liquid into this one, into this beaker. What I'm going to do, I'm going to dip this pipette into the liquid. I'm going to put a bulb on top of this one, squeeze it, put it on. Then I'm going to slowly release my pressure on top. I hope you can see the water is coming up from into the pipette. I'm going to keep draw it up above the mark. I'm going to remove the bulb and put my thumb on top of the pipette right away. When I put my thumb on there, this liquid stays there. It doesn't drop. Okay, so you can transfer it to anywhere. However, now the volume is way above the 10 ml mark. So I'm going to release some of the liquid here to make sure the liquid surface stays right on the 10 ml mark. All right, 10 milliliter. I'm going to transfer it. Now, what I'm going to do, I'm going to move my thumb away, and the liquid is coming out. Okay, liquid doesn't drop out anymore. There might be a little bit of liquid at the tip here. I'm going to use the tip, let it touch the wall of the beaker. That's it. You may see that, okay, you see what? There's still some liquid inside the pipette. You do not want to blow that part of liquid out. You do not want to blow it out to your container. The pipette is pre-calculated with a little liquid at the tip. If you blow it out to your sample, you transfer more than 10.00 milliliter. Okay? So that little amount of liquid stays there, you transfer 10.00. Okay? We're going to measure the mass of it. Zero the balance. 41.89 mass of beaker and liquid 41.89. Then you do the calculation, make sure follow the operational rules for sig figs. Okay, now I'm gonna do another set of measurement and I'm gonna give the data right away. Data for trial number 2, temperature didn't change, 23.0. The mass of another 50 ml beaker, it is 28.18. I didn't use the last beaker. So another mass of 50 ml beaker, another set, 28.18 grams. Eventually, the mass of beaker and the liquid together is 38.42. Okay, this is the data of the second set of measurement. Okay. Now, after your calculation, you get the average. You need to go back to book table 2.2. Densities of selected liquids. You have to make a decision based on your data and the data in that table. Make a decision. What do you think the unknown liquid is? Okay. Well, what I can tell you clearly, okay, looking at the data, you also need to look at the sample you used. Regardless what data you get, I can guarantee you this is not milk. Do not say my sample is milk because it is the same data as the milk. This is not milk. You have to use your common sense as well. Okay? So we have finished all the 3 measurements. One last time, I want to remind you, when you do operations, calculations, and measurement, pay attention to the operational rules for sig figs. All right, see you next time.